Hello and welcome to Math 252 Calculus 2 here at Cañada College. My name is Ray Lapuz. In this video we will take a quick look at a problem from section 2.1. This is number 11 from the homework. And here we have a picture of a graph. The graph above shows the base of an object. So this is going to be a three-dimensional volume object. Compute the exact value of the volume of the object given that the cross sections perpendicular to this base and parallel to the y-axis are isosceles right triangles with their hypotenuse on the base. So let's imagine one of these cross-sectional cuts, and I'm going to just make a random slice over here. There's actually going to be two different problems that we're going to put together. But here one random slice would look like that. And so this is looking at the object, the solid, directly from the top. And let's draw the corresponding cross-sectional cut matching the base here. Now they said that this is the hypotenuse of an isosceles right triangle. So I would imagine the right triangle would go something like this. And this is a right angle, and this is the hypotenuse. And the idea here is to find this area of this hypotenuse. So we know that if this is some value A and this is another value A, oops, let's call it A, then as a right triangle with a 45, 90 degree relationship, this is going to be A times the square root of 2. So if the side is 1, the other side is 1, then the hypotenuse is going to be square root of 2. If the side is 5, the other side is 5, the hypotenuse will be 5 square root of 2. Now we want to find the area of this. The area of this is going to be 1/2 base times height. So the base is, we have to look at this sideways from the right triangle point of view. The base is going to be A, and then the height is going to be A, so this is going to be 1/2 A squared. But we have to make the connection to the actual axis that we're looking at. And by that, I mean this x-axis that we're looking at, because we want to eventually write this as a function of x, so a of x. So before I do that, let's move this for a second. Before we do that, to get our relationship between them, we need to make this relationship and call this A times square root of 2. So this whole length over here is going to be A times square root of 2. Now, according to this graph, if we're looking at this graph, I'm looking at this line from 0, 0 to 2, 6 to be the line y is equal to, and it's the x and y coordinate are 0, so it's just going to be the slope. The slope is rise over run, so that's 2 over 6. So the slope here, m, is equal to 2 over 6, or that would be 1/3 x. So if you draw the line 1/3 x, you'll see that it'll pass through 0, 0, and it'll pass through this point 6, 2. So now that we have that slope, this distance from the x-axis to that graph is 1/3 x for some x value that we randomly chose. But we want the actual base, and that actual base is actually twice that. So we will rewrite this base as 2 times 1/3 x. So it's like twice that y-axis. All right. So keep in mind that our area is 1/2 A squared. So what we want to do is we want to solve for A and write it in terms of x. So in this equation, I'll solve for A by dividing by root 2. And so this would be 2 in the numerator, 3 in the denominator, and we'll also divide by root 2. So 2 over 3 root 2 times x. So that's what our A is. And now let's come back to this equation, or this relationship between the area and this value. So the area for these triangles will be a function of x. It'll be 1/2, and then it's going to be a squared. A is equal to 2 over 3√2 times x quantity squared. And we can do some simplifying if we want. I think this will become a 2 squared, and this will become a 2, so that'll cancel one of the 2's, it'll cancel another 2 here, and then we will have a 1/9 for the 3 cubed and then x squared. All right, so that is our a of x. So our formula for the volume, by the way, volume is going to be equal to the integral from some a to b value of the function a of x dx. So it's as simple as that. Unfortunately, this particular problem has an area that's changing in this certain way as we go from 0 to 6. From 0 to 6, we will have this relationship here. So x between 0 and 6, it's going to be changing in this manner. So we can integrate our volume, will be the integral from 0 to 6 of 1/9 x squared dx. Now that only takes care of the area up to this point. After that point, what we have to do is we have to find another relationship between our cross-sectional cuts in our base. So let's imagine another set of triangles here with the base given by this line. And we, again, will be looking at A and A here. But now notice that as we make any cuts between 6 and 8, x is equal to 6 until we get to 8, our lengths are not going to change. So this is going to remain constant. And what is that length? That length is going from -2 to +2, so that length is actually 4. So this will remain constant at 4. And if we follow through the same steps that we were looking at, A, big A for the area is going to equal to 1/2 a squared, and that's the area, and then we want to figure out what A is equal to in this scenario. So this is going to be a squared of 2, so a squared of 2 is equal to 4, or we can write A is equal to 4 over square root of 2. Now that we have that, we can put it back into this equation, and we're going to get, let's put it down here, A of x in this scenario is going to be equal to 1/2 times a squared, and a was equal to 4 divided by square root of 2 quantity squared. And notice that there's no more x's, and that makes sense because your value or your area is not going to change as you move along there, as you move along the x-axis. So here it's just a constant. All right, if we simplify this, we're going to get 2 squared. This is going to be 16 divided by 2 times 2, and so that's just going to be 4. So your area for all those isosceles triangles will always be 4 in this particular scenario. Now that we have that, we will add on this integral from 6 to 8 of the area function, which is just constant for dx. Okay, so from here we should just integrate. The 1/9 is a constant, we'll take that out, 1/9, and then the antiderivative of x squared is 1/3 x cubed, and we're going to integrate this from 0 to 6. So this thing is just going to be 4x, and x is going to be integrated from 6 to 8. So that's just going to be, well, let's take a look at this. This is 1 over 27 times 6 cubed minus 0. So we'll work that out. I believe that 6 cubed is 216, and then we can actually divide 216, well, 216 over 27, we'll figure that out. This next one, 4 is constant. This is just 8 minus 6. This is 4 times 2, and 216 divided by 27 is 8, and this is also 8, so we have a total of 16. 16 cubic units, whatever the units are, and that should be your result. All right, so the key is, this is our formula. The volume is going to be the integral of some area function, and you can see the area function changes from 0 to 6, so that's why our area function is dependent on x. And then from 6 to 8, you see that the area will not change. Your area of your triangle is always going to be the same, and that area happens to be equal to 4, and then that should be your result. And you put that in the integral, your area functions, and then you integrate and get your result. Okay, I hope that helps. Good luck.